All right. In question number 1, is everybody with me on the quiz? To the nearest whole number, find the radius of a circle with the circumference of this. So what is the formula for radius and circumference? The 2 pi r? So then you just substitute in what you need to know. 106.81 equals 2 pi r, and you solve that equation. So 86% of people got this question right. So I don't know that I need to do anything more than just that. Are there any questions on that? All right, then let's move on to number 2. Number 2, to the nearest whole number, find the diameter of a circle with the area of 95.03. So this one is a couple of steps. We don't have a formula for area and diameter, but I know if I have area, I have to use area equals pi r squared. So you fill in everything you know. 95.03 equals pi r squared. Divide by pi and divide by pi. And then once you get that answer, you need to take the square root. So you need to take the square root of that answer to get rid of the square. And that's going to give you the radius. So r equals the square root of 95.03 divided by 5. And then to find the diameter, you need to multiply that by 2. So you want to put all of that in your calculator. And again, 86% of people who did this got this question right too. So I don't know that I need to go into any further detail than that. Any questions? It's just algebra. Find the formula and substitute it in. Question number 3 is always a low question, and I'm always surprised by it. So what relates the circumference and the diameter? I know that area equals pi r squared, that's my weird pi, and circumference equals 2 pi r. Circumference also equals pi d. So if you don't remember this formula, you can use this one, but this guy is a lot easier to use in this case. So if circumference equals pi times d, and it equals 2, oh my goodness gracious. I need to erase some of this. Let's try this again. If circumference equals pi times diameter and it equals 244 pi, how do I solve just this part of the equation? Divide by pi and divide by pi, those go away, and the diameter equals 244. And that's that. Questions on that? So don't discount this formula. If you used this other one, you could use C equals 2 pi r, and C equals 2, I don't know why I keep writing 24, pi equals 2 pi r. You can divide by 2 pi and divide by 2 pi, and you get r equals 122. If you know r equals 122, then you know the diameter equals twice that. Okay, I'm just going to keep pushing on unless there's questions, so I need you guys to speak up. This question was keyed in wrong, so there was not a correct answer in the answer key for this one. I have since changed it, and now there is a right answer, but I would like to go over this one. What is the closest area to the circle? So area equals pi r squared. This is my diameter, so I need to cut it in half to get the radius. So if I do 11.4 divided by 2, I'm going to get 5.7. So area equals pi times 5.7 squared. When you do that math, you should get the right answer. Any questions on that?
Those are the same answer choices as the other one.
There was one that was different. I changed it. So there is a correct answer now.
Should we just use that one?
Is it not giving you the choices on my screen?
Mine is.
There should be a correct answer now.
Okay.
Yeah. This one was fantastic. 100% of people got this right. So if I have a minus 5, I need a plus 5, right? And if I have a plus 1, I need a minus 1. And then the radius is going to be positive. The radius always has to be positive. I can't have a negative radius. So if you eliminate all the things that it can't be, you're left with one thing that it can be. So this one's a little trickier because it's asking for the diameter. And we know that this is the radius, but it's squared. So if over here I do 40 equals r squared, what do I have to do to find just the radius? Take the square root. So r equals the square root of 40. And I know the diameter equals 2r. So diameter equals 2 times the square root of 40. The problem is I don't see that over here, right? So what I'm going to do is because I don't really like radicals that much, to be perfectly honest with you, I'm going to change this into a decimal in my calculator. And then I'm going to go look at all of my answer choices to see which one matches. So it's definitely not 40 and it's definitely not 80. If I put 2 times the square root of 10 into my calculator, I get 6.32. And if I do 4 times the square root of 10, I get 12.64. So which one is my answer choice? B, yeah. So if you're ever stuck with that, just walk through all of the things that you know. You know this is the radius squared, so you have to take the square root. You know the diameter is twice the radius, so you have to double it. If your answer choices don't match and they have weird radicals or fractions in them, just simplify them into decimals and then compare the decimals. Yeah.
What if they question 4 was?
Well, let's go back and look. So question 4 was the one that didn't have a correct answer in the original thing. So if you've already opened your quiz and didn't submit it, you might not have all of those answer choices. You might have to look again to see which of those answer choices is going to be correct. Do you have all of those numbers? So if you put that in your calculator, you should get one of those numbers. And then somebody asked me about number 2. So for number 2, you want to put everything into the area formula to find the radius. So you want to take the area, divide it by pi to get rid of the pi, and then take the square root. So you're going to get the square root of 95.03 divided by, that should be a pi, divided by pi, and then square it. That's an exponent. So over here, you're going to do the square root of 95.03 divided by pi, because that gives me the area, and then you're going to square it. So all you're doing is solving this formula. Oh, and it's not squared, it's multiplied by 2. I can't even read my own notes. The struggle is real. So you're going to multiply by 2 and multiply by 2 because that's radius times 2 equals the diameter. So radius times 2 equals the diameter. Does that help? All right, question number 7. I think this is the last one for circles, or maybe there's one more for circles. There's 2 more. Okay. The center and a point on the circle are shown. What is the equation of the circle? So sometimes I like to kind of imagine that there's a circle there, right? If I know that this is the center, I know my equation has to start with a -2. So it has to start with a -2. I can eliminate those 2 answers. And then it has to have a +1. So it's got a +1 and a +1. Now I need to figure out what that radius is, right? Is the radius 3 or is the radius 5? So I can use the distance formula. X minus x squared plus y minus y squared. So that's 3 squared plus 4 squared, which is going to be the square root of 9 plus 16, or the square root of 25, or 5. The other way to do it is to draw that triangle. And you know this is a right triangle. Oh, that's my 4 side, and that's my 3 side. So that's got to be a 5. So knowing the center pattern, you can at least get it down to a 50-50. And honestly, if you look at this, it's got to be longer than 3. So it really can't even be the 3, just looking at it visually. Question on that one? I know we didn't spend but like a little part of a day on circle equations. Circle with the center at 4, 3 contains a point of 9, -3. So let me show you a shortcut way to do this. If you open up your Desmo, right, and you'll have access to Desmos, we can type in everything that we know. And honestly, we can maybe shorten this a little bit, because if I know the circle center is a +4, -3, I know it has to be a -4 in my equation and a +3. So these are my only 2 choices, right? So if I open that Desmo back up again, and I type in those 2 answer choices exactly the way I see them, y plus 3, and then equals 25. Did I type that in right? -4 plus 3 and 25.
Yeah.
Okay. And then I type in my other one, x minus 4 squared plus y plus 3 squared equals 81. I've got 2 circles, right? I always double check to make sure I typed them in right, because a lot of times I do weird things when I type. And then I want it to have a circle center at 4, -3. So I can plot 4, -3 and just make sure that I didn't do anything weird. And that's definitely my circle center, so that looks good. And then I just plot this other point, 9, -3. And it's on the red circle, not the purple circle. And my red circle is that -4 plus 3. So it's got to be this -4 plus 3 with a radius of 5. You can do this with distance formula. It's just a little more cumbersome. You can also plug this number back in. So the way to do this, if you prefer algebra, and you can do this to double check, I think this is my right answer. So let me plug that number in. oops. To my equation. So if this point is on the circle edge, it should make this equation true. So 9 minus 3 squared plus that y is -3. -3 plus 3 squared equals 25, right? Contains the point 9, -3. 9, -3. Okay, so 9 minus 3 is... Why does this seem like it's not going to work? 9 minus 3 is 6. So 6 squared plus -3 plus 3 should be 0 equals 25. Oh, because I put a 3, not a 4. Come on, y'all. You need to help me out. That's a 5. So 5 squared equals 25. And I know that's my right answer. So just to recap, if you get a question like this, you can always put it in Desmos. If you're not sure what to do, put it in Desmos and see if the picture will help you, okay? If you're not sure that you can cancel out these two because of the circle center, put all 4 equations in. It's just a matter of time to type them in. Does that help a little bit? I know a lot of people struggled on this question. The diameter of the circle below is 3.5 inches. So the diameter is all the way across, and that's 3.5. So what's the radius? Anytime I'm given a diameter, I usually find the radius. (3.5 divided by 3.5 divided by 2 is 1.75.
Yeah.
A, B, C, and D and E are equally spaced. So this arc and this arc and this arc and this arc and this arc are all equal. So if the whole thing is 360, what's this space here? 360 divided by 5. So if we do 360 divided by 5, it's going to be 72. Each one of these spaces is 72 degrees. So then how do I find that arc length? That's our formula from yesterday. So 72 degrees divided by 360. And then do I do area or circumference? Circumference. So 2 pi, and then we've got to use the radius of 1.75. There are a lot of pieces of information to figure out in this problem. 72 divided by 360 times 2 times pi times 1.75. I'm tired. And what is the best answer? Anybody got an answer for that? Absolutely. Thank you. The circle for a game spinner is divided into 3 regions as shown. RP is the diameter. So RP is a diameter. What is the area of the shaded sector? RP is 8. So if RP is a diameter and RP is 8, what's the radius?
4.
4, absolutely. And if this piece is 45 and this is a diameter, then half of that is 180. So what's this gray piece? 180 minus 45 is going to give me 135. And that was kind of the key to this question. You had to notice that RP was a diameter, so the radius is going to be 4. And then you had to know that this was cut in half because it's a semicircle, which means this arc, this angle here is going to be 135. Once we know those 2 pieces of information, what formula do we use? 135 divided by... And then pi r squared, because we're looking for area, right? So if we put all that into the calculator, oh, one more thing. I noticed there's pies here. I think we only did one example like that yesterday, right? If there's pies in your answer choice and you notice before you put it into the calculator, don't use pi in your calculator. So 135 divided by 360 times 4 squared is going to give me 6. Then I can put the pi back in. So if there's pies in your answer choices, don't put it into your calculator and then put it back in at the end. I'm so proud of everybody who got that question right. Over half of you got that right. That's fantastic. The next 3 questions looked really good. What's the closest area of the shaded sector? So the radius and the arc. So we're going to use our arc, 130 divided by 360. And then we want area. So we're going to use the area formula, pi r squared. There's no pi's in the answer choices, so you just let your calculator do the heavy lifting. Put all that into the calculator and get the right answer. And you're going to round to the nearest, to the closest number. Questions on that one? 86% of you got that right, so that's fantastic. Number 12 gives us a little left curveball, okay? So the circumference of the circle is 216 pi. What is the length of the arc? So I definitely want circumference because I'm looking at length. And this is 120. So we substitute our equation exactly the same way. 120 degrees over 360 degrees, always the part over the total, and then we multiply by the circumference. And if the circumference is 216, we just write 216 pi. There's no need to know the radius. There's no need to calculate the radius. We don't have to do anything. If we have pi in our answer choices, then we do not put it in our calculator. So all you're going to do is do 120 divided by 360, multiply that by 216, and then add your pi back in. So whatever number you got, and then the pi. Questions on that? You can always put it in the chat if you've got a question. Last one. If the radius of a circle is 10, so we can add that into our drawing. What is the length of arc AC? So the length of arc AC. So again, we're going to do the 166 over 360. We're looking for arc length. So do we use circumference or area? Circumference. So 2 pi 10, because we're going to do 2 pi r. And then you just put all of that into your calculator. 166 divided by 360 times 2 times pi times 10. And voila! We have a correct answer. Was it helpful to review them?
What was number 9?
What was number 9? Let's look. So we took that circle and we divided it into 5 pieces and got the 72 degrees. And then we put it into our formula. And you had to make sure that you knew the diameter was 3.5, so the radius was 1.75.
Okay, thank you.
You're welcome. Number which one?
I mean 11, sorry.
11? So if we're looking for the area is pi r squared. You just have to remember that formula, the angle over 360, and then either multiplied by the circumference or multiplied by the area. Any other questions? Yeah.
This set number 10 is wrong.
Set number 10 is wrong?
Yes, it's not the 6 pi.
Let's reread the question and see what we did wrong. A circle for a game spinner is divided into 3 sections as shown. RP is the diameter. What is the area of the shaded sector ROS? If POS is 45. Do you guys see anything that we did wrong? RP is 8, RP is 8, RO is 4, 135, 180 minus 45 is 135, right? 135 divided by 35 divided by 360, and then times 4 squared is 6 pi. All right, let me go check on that. Are there any other problems? I need to stop sharing for a second so I can go check that. There we go. All right. So if I've got central angles, those central angles are what's here in the middle, right? This green is the central angle. It meets at the center of the circle. In this one, the 120 is the central angle. It's the blue angle that meets at the center of the circle. One thing about central angles is this angle here is exactly the same as this arc length out here. Okay, so central angles meet at the center of the circle. Central angles meet at the center of the circle. Inscribed angles meet at the edge of the circle. So this angle here is my inscribed angle. Okay, the inscribed angle is at the edge of the circle where the central angle is at the center of the circle. It kind of makes sense. So there's a relationship between this inscribed angle and the central angle. If the inscribed angle is 30, then the central angle is 60. The central angle is twice as big, and it looks bigger, right? So the inscribed angle is small. If it's 60, then the central angle is twice as big. Okay, so there's a relationship. The inscribed angle, if that's x, then the central angle is twice that, and the arc outside that central angle is the same as the central angle. Okay, so that's kind of the relationship that we've got going on today. So let's see what that looks like in practice. This is a page straight out of your notebook, right? And then I added a little bit to it. So in the Pear Deck, you can't watch these videos, but in your Circles notebook, if you want to, you can go back and watch these videos. So if I know that B is my central angle, it's 84, then arc AC is also 84. And I want you to write that on your Pear Deck. Okay. The other thing we need to know is the sum of all of those central angles is 360. So if I know the blue angle is 64, or 84, then what is this space here? That's going to be 360 minus 84. So in your calculator, what is 360 minus 84? Anybody get 276? I beat you to it. So the measure of arc AC, that's that pink arc, is going to be 84. The measure of the major arc from A all the way past D and then all the way back to C is going to be 276. 276. And notice that I've got the arc. There's like a new symbol there. It's like an arch instead of a flat line for a segment. So I'm going from A past D all the way to C. This is how it's noted to go all the way around the circle the long way, right? So central angles meet at the center. They're always going to add up to 360 degrees, and the arc and the angle opposite it are always the same number of degrees. Does that kind of make sense? So let's practice. We've already done this example, just a little bit bigger over here. So let's see if we can answer these questions. What's the measure of arc JK? So arc JK is going to be this one here. What's that measure? If the angle is 21, then the arc is going to also be 21. Okay, I'm going to try to get a new color. And then J to N to M, and that's an angle, JMN. So if I start at J and I go to N and then I go to M, I want to know this green angle here. Well, MNK is the diameter, right? So these two, the green and the orange pieces, should equal 180 degrees. So if I do 180 minus 21, what do I get? Minus 180. So I just want this green part on that 1/2 of the circle. So do 180 minus 21. Do you get 159? So this green part here, and we're only doing half the circle, is 159. The other half of the circle is the other 180. Okay, so I'm just getting a new color. It's a little hard to look at when it zooms in and out. I know. If you need to, close your eyes. And then KL, I've got an arc here, so I'm looking for the arc. Arc KL. Are these vertical angles?
Yes.
They are. So both of these blue arcs, the angle, the central angle and the arc opposite it are going to be 159 degrees because they're vertical. Okay, so you can have vertical angles in a lot of different shapes. All right, arc JKM. This is where it starts getting a little crazy. So I'm going to start at J. I'm going to go to K. And then I'm going to go to M. And I like to put dots on those three things and then go from one to the next. It's like I'm going from John's house to Karen's house to Malik's house. Okay, from John's house to Karen's house to Malik's house. I've got to go from J past K and then all the way to M. So I need to add up all of those things. I know the 21. I know the 159. What's this angle here? 21, because the orange and the purple are vertical to each other. So for that JKM arc, I need to add 21 plus 159 plus 21. In my head, I feel like that should be 201. Is it 201?
Yes.
Awesome. And remember, these are all degrees. 201. So now MKL, you think about that while I get a new color. MKL. Here I want to start at Malik's house and go to Karen's house and then go to Laura's house. So if I need to go from Malik to Karen's and then back to Laura's, I'm going to go around the circle this direction. Okay, from Malik to Karen to Laura. That means I'm not doing this little piece here. So you can either add all of those pieces, 159 plus 21 plus 159, or you could do 360 minus the piece that you don't use. Some people like to do the addition and some people like to do the subtraction. It should give you the same answer. So I think it should be 3 something 9. What's that middle number? Is it 339?
Yeah.
Awesome. Okay. So when you've got 5 different things, the picture starts looking a little crazy. Just remember that semicircles give you 180 degrees. You've got some vertical angles, and the central angle and the central arc are always the same number. Okay. Let's go to slide 3 and do a little bit more practice. So what do we know from slide 3 or from number 3? Can we find CD?
Yeah.
What is CD?
90.
90, absolutely. So sometimes before I even go to the rest of them, especially if it's like this, I know that this is a semicircle and this is a semicircle. So that has to be 90 and that has to be 90. I just fill in everything I know. That means these two together have to be 90. So what is 90 minus 34? Ninety minus 34. Is that 56?
Yeah.
Okay. So I like to fill in all of my angles first before I start answering any of the questions. I feel like it makes my drawings a little less cluttered, makes my life a little easier to look at. But you got to figure out the best strategy for you. I'm intentionally slowing down a little bit because I know I write faster than you guys do. On the Pear Decks, it's tough. So CD is 90. That's the easy one. I'm going to get a new color to do FD. So I put a dot at F and I put a dot at D, and I want to go the most direct route from F to D. If I only have 2 numbers, I want to go the most direct route. So if I go from F to D, Frank's house to Daryl's house, then I'm going to do 34 plus 90, which equals what?
124.
Awesome. And then C, D, C, F, I want to do those in order. D, C, F, D, C, F. I've got to go to C first. So it's like I'm picking up dinner for my grandma at my mom's house, and then I got to take it to my grandma's house, right? So I've got to go from D to C to F. So that's going to be 90 plus 90 plus 56. And what'd you get for that?
236.
Awesome. And then same thing for that last one, G to D to F. The thing to remember is to go from G to D and then to F without backtracking. So G to D to F. I can't go past F to get to D, so I've got to go this way. So again, you can add all those parts, 90 plus 90 plus 90 plus 34 if you like to add, or because you're doing everything except this one piece here, you can do 360 minus 56, whichever way you prefer. Some people only like to add, and some people only like to type a few numbers. It's really your preference. So we get 304 question mark. Did I do that right?
Yeah.
Okay. And again, these are central angles. And central angles are congruent to their arcs. We ready to look at number 5? Number 5 is a little easier and a little harder at the same time. So you have to recognize that RVT is a diameter, which means this arc is a semicircle. How many degrees in a semicircle? If the whole circle is 360, then half of that is going to be 180. So if this piece is 15x minus 26, and this piece is 26, what equation can I write?
15x minus 26 equals 180.
And then we've got to add in that plus 26. Absolutely, yep. And then it equals 180. The part plus the part equals the total. So we combine our like terms. We've got minus 26 and plus 26 that are going to cancel out. So we've got 15x equals 180. And then what does x equal? 12. I didn't even have time to pick up my calculator. Awesome. I know that was kind of fast, and it was kind of a lot to think about. How are we feeling about central angles?
Good.
Awesome. So let's go look at inscribed angles. This page is a lot to look at, okay? So bear with me. We're going to kind of flip back and forth from the right to the left. At the end of the day, we need to know that the inscribed angle is x and the arc is 2x. So the inscribed angle is x and the arc is 2x. So if arc AC over here on the right side is 2x, what's angle B? If the arc is 2x, it's twice as big, then the inside is going to be half of that, right? So 78 divided by 2, I'm over here on the right side, 78 divided by 2 equals what? 39. Absolutely. And this should say an inscribed angle. I'm just seeing that. It's a little typo. Inscribed angle, not central angle. Okay. So let's skip over to the right side, and I'm sorry we're going back and forth a little bit. WXV on the left side. If this arc is 62, what's the angle? 31, absolutely. So when we have inscribed angles, it's just half. The outside is twice as big as the inside is half as big as the outside. Okay. There are some special cases though. So if we have a diameter over here at P, we know that's 180 degrees, right? Which means this angle has to be a right angle. So that's going to be 90. It's still an inscribed angle, right? It's just a special case. We know the diameter is 180. If I jump over here to the left, BC, that's 180. So angle A has to be a right angle. Kind of hard to see. So if we look here at 3, PSR is a diameter, so that's 180 degrees, which means what angle is the right angle? Angle Q is 90 degrees. So these 3, 1, 2, and 3 are special cases. There's still those inscribed arcs. It's just that when there's a semicircle, it's 180. So we know 100% that that third angle is going to be a right angle. Okay. The next one on this page is the one that's kind of crazy. Okay. Anybody do drama? Anybody have any like practice being on stage? No? Oh my gosh. My mouse has lost its mind. Okay, maybe this will work. Woo. Okay. All right, I'm going to zoom in real big on this one. If B is a spotlight on a stage and it's shining this way, it's lighting up AD, correct? And then C is another spotlight and it's lighting up the stage. It's also lighting up AD. So if AD is 2x, then B is x and C is also x. They're the same. That yellow is really hard to see, so I'm going to get a different color. So if this is 2x, these two angles here are equal because they overlap. And if you kind of think about flashlights lighting up something or spotlights on a stage, sometimes that helps. So I've got another example over here that's already kind of color-coded for us. If A, B, D is a spotlight, it's going to shine on AD. That's going to be my 2x, which means the angle here at B is going to be 1x. It's going to be exactly the same as this angle because they light up the same part of the stage. Okay, that one's the hardest one to kind of look at. So we've learned three things here. Inscribed angles are small and the arcs are big. And the relationship is two of the small angles make one of the big arcs. If that line is a diameter, then the angle is 90 degrees because 180 divided by 2 is 90. Let's see if we can make some sense of this by going to slide 5. And these are the last of our notes. Oh, you know what? It is 8:50. What I want you guys to do, we're going to end class right here, is we'll finish slide 5 on Tuesday. Do as much of your IXL as you can and see if you can look at this homework and make sense of it. Basically, you're going to write one problem for each of these 4 kinds of things, upload a picture to the media album, and then answer a question. Okay, so I put an example.